to the countdown.
Tahniah! Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Assalamualaikum warahmatullahi wabarakatuh. And good evening, teachers, parents, and all wonderful students. Welcome to Pusat Tuisyen Academy YouTuber Bermula Percuma, Selamanya Percuma. How are you doing today? I hope all of you are ready for today's lesson. Before we proceed, let's begin our session by reciting Kitab for Muslim, and for non-Muslim may pray according to your own religion. Al-Fatiha. Amin, amin, ya Rabbal Alamin. Let me introduce myself. I'm Cikgu Shahnon from Penang Matriculation College, the moderator of the day. We at Pusat Tuisyen Academy YouTuber will provide you with free online classes. Let's take this opportunity to do your revision. So, are you ready? Okay, let me introduce our teacher for today's lesson. We have Teacher Tang from Selangor Matriculation College. How are you, Teacher Tang?
Oh, good.
Okay, good. We now live on Teacher Tang's channel. Please support her channel by clicking subscribe now. The topic of today's lesson is Benzenes Part 1. And together with us, we also have Cikgu Mawa, who is control host in charge ensure the smoothness of our lesson on technical support. How are you, Teacher Mawa? Good,
Fine.
all right. Last but not least, Teacher Kong as an observer. How are you, Teacher Kong? Madam Kong.
Yeah, I'm
Teacher Kong,
great.
Madam Kong. Yeah, great.
I'm great.
Okay. All right. Okay, before we begin, I have a few reminders to all of you. First, please pay attention to our lesson. Stop chatting and use the chat session wisely. Number two, regarding to certificate link, the link will be given at the end of our session. Please use EDD, MOE, My Guru, and My Jawi account when you fill in your particulars. Make sure you fill in the form within time limit 30 minutes. All right. Okay, especially for the student, I announced the passcode for IU credit. For your information, the passcode will be announced 3 times, at the beginning, in the middle, and the end of the broadcast. Our first passcode, our passcode is letter A and number 2. I repeat, letter A and number 2. So without further ado, the Teacher Tangs is welcome to present Benzenes Part 1.
Okay, thank you, Teacher Shannon. So I'm Teacher Tang from College Matriculasi Selangor. So I have 9 years of experience teaching pre-U chemistry. So these are my teammates for chemistry pre-U group. So we all led by Cikgu Shannon, the moderator of the day. With us, we also have Teacher Bibi Lau. Cikgu Mawa is the control host, and also Madam Korn, she is the observer for today's lesson. Okay, so beside chemistry pre-U group, we have the mathematics pre-U group led by Teacher Ying, and also the biology pre-U group led by Cikgu Faiza, and also the physics pre-U group led by Madam Rosmaya, and also the econs and accountant, so led by Madam Fizi. Okay, so now we move on to benzene and its derivative. So our lesson for today's class. So first, introduction. So benzene usually been drawn in calculate structure form. So this is calculate structure proposed by calculate. Okay, so calculate proposed benzene to be drawn in such a way that in a ring structure. Okay, 6-member ring. Okay, and then having alternating single, double, single, double, single, double bond. Okay, so it can be drawn this way or this way according to calculate. So basically, these two calculate structure of benzene, okay, so proposed by calculate, and calculate said that why there are two structures of benzene, it is because benzene can interconvert between these two structures very quickly. And this is the structure that is proposed by calculate. Okay, however, if benzene really in the calculate structure form, then means that it will have two different bond length, because this is single bond, and we know that single bond is weaker compared to double bond. So therefore, we will expect the single bond to be longer than the double bond. However, analysis proved that in benzene, all the bonds are of same length. All the 6 bonds are of same length. Because of that, benzene actually is not in the calculate structure form as been proposed by calculate. So what is the most accurate way of represent benzene structure? It is basically in the resonance hybrid structure form, whereby the 6 pi electrons, they are equally distributed among all the 6 carbon. Okay, and since it can be delocalized among all these 6 carbon, therefore the best and most accurate way of drawing benzene is having we draw the ring within the benzene ring, okay, to represent the resonance hybrid structure of benzene. This is the most accurate structure of benzene, okay. However, calculate structure is still very important, especially during the mechanism where we want to show how the pi electron is being used to form bond, and then the bond breaking to restore the aromaticity of the benzene ring. So therefore, calculate structure is still very popular, okay, to be drawn, especially in mechanism to explain the electrophilic aromatic substitutions reactions of benzene. So now, just now I mentioned about aromaticity. So basically, benzene having these aromaticity properties. Okay, so what is aromaticity? Okay, so aromaticity basically refer to a compound which fulfill a certain criteria. So the first criteria a compound must fulfill in order to be aromatic is the compound must be cyclic. Okay, must be in the ring form. Okay, and then it must be planar. Okay, so planar means that at each of the atom, it need to be sp2 hybridized. Okay, so you have learned the geometry last semester. So sp2 means that referring to trigonal planar geometry. So with each of the atom being sp2 means that they are having the trigonal planar structure, and therefore the structure will be planar. Okay, will be planar. Okay, so when each of the atom being sp2 hybridized, okay, they will have one unhybridized p orbital. Okay, and this unhybridized p orbital must consist of pi electron, and then they will overlap to form a continuous ring or parallel orbitals like this. Okay, in order for the pi electron within to be delocalized, means that can move around within these 6 members. Okay, 6 carbon in benzene. Okay, and it must be completely conjugated. Okay, so the simplest way to explain completely conjugated basically is having the alternating single double bond. Okay, so and the last criteria of aromaticity is that particular compound must obey Harker's rule of having 4n plus 2 pi electron, where n can either be 0, 1, or 2, or so on. Okay, the whole number. Okay, so benzene having 6 pi electron. Okay, so 6 pi electron. So therefore, okay, pi electron. So 6 pi electron. So therefore, the n is equal to 1. Okay, so n is equal to 1 for benzene. Therefore, means that benzene obeys Harker's rule. Okay, and it is completely conjugated, and it is planar, and it is cyclic. Therefore, benzene is aromatic. Okay, having the aromatic aromatic character. Okay, so and benzene basically being aromatic causes it to have extra stability. Okay, so benzene by being aromatic, it will have extra stability, which will affect its chemical properties, which I will discuss later on. Okay, so now we move on to look at the IUPAC nomenclature for benzene and its derivative. So the first one, if we are having mono-substituted benzene, then how do we name the compound? Okay, so basically, if we have mono-substituted benzene, the benzene must become the parent, okay, and the substituent will be the substituent will be indicated by a prefix. Okay, so what does it mean? So like for example, we have this compound here. So the benzene is the parent, so called as benzene. And the substituent here is bromine. So bromine being the substituent, we call it as bromo. And we need to write it, indicate it by a prefix. So means that write it in front. So therefore, this compound is called bromobenzene. Okay, so the second compound here also the same. So the parent is the benzene. Okay, so the benzene ring, and the substituent here is chlorine. And when chlorine becomes substituent, we call it as chloro. Therefore, this compound we call it as chlorobenzene. So sometimes the substituent can also be incorporated to become part of a parent. Okay, like for example, the first compound here, the methyl group can be incorporated into benzene to become part of a parent. And this compound, where methyl being incorporated into benzene and become part of parent, we call it as toluene. Okay, so the second compound here, we have OH hydroxyl group be incorporated into benzene to become a parent. So this compound, we call it as phenol. Okay, so if we have amino group be incorporated into part of benzene to become a parent, we call it as aniline. Okay, so if we have carboxyl group incorporated, become part of benzene to become a new parent, we call it as benzoic acid. Okay, so if we have carbonyl, this is aldehyde, the carbonyl, okay, aldehyde, be incorporated into benzene to become a new parent, we call this as bens. Bens here refer to benzene, okay, Okay, and this is carbonyl aldehyde. So therefore, we call this compound as benzaldehyde. So benz here refer to benzene, and aldehyde here refer to this functional group. Okay, so the next one. So the next one, we have this group. So this is ketone. So having 2 carbon ketone being incorporated into benzene to become a new parent. So we call this as acetophenone. So basically, before having the IUPAC nomenclature, so people started to name compounds. Okay, so before having the IUPAC nomenclature, 2 carbon, they call it as acetal. Okay, or some people call it as acetyl. So therefore here we have 2 carbon, so therefore the name is acetal. So refer to these 2 carbon, and phi here is referring to benzene ring. So later on we are going to look at if benzene becomes substituent, it is called phenyl. Therefore phi here is referring to benzene, and on here is referring to ketone. So this functional group is ketone. Okay, therefore this compound we call it as acetophenone. Okay, acetal, 2 carbon, phi here referring to benzene, on here referring to ketone. Okay, so these 6 compounds, okay, where having 1 substituent be incorporated into benzene to become part of parent. So it's very important for you to know their name, okay, because we are going to use them to name other benzene derivative later on. Okay. So now we move on to look at the IUPAC nomenclature for di-substituted benzene. So for di-substituted benzene, we need to indicate the numbers of the substituent. Okay, so by indicating the positions of the substituent in the benzene. Okay, so if the substituent is in 1, 2 positions to one another, okay, so we can indicate it using auto. Auto means that the 2 substituents are in 1, 2 positions to one another. So if the substituents are in 1, 3 positions to one another, so we indicate it by stating meta, or we just write M. Okay, so 1, 4 from one another, so it is called para, so we indicate it with P. Okay, so now we move on to look at how to name di-substituted benzene with 2 same substituents. Okay, so the first compound here, can you see that the 2 substituents, they are the same and they are in 1, 2 positions to one another. So 1, 2 position is auto, so we indicate it with O. And then there are 2 bromine, so therefore we call it as dibromo. And benzene is the parent. Therefore, this compound is called auto-dibromobenzene. Okay, so we move on to look at the next compound. So the next compound is this. So can you see that the 2 substituent is at 1, 3 positions to one another? So 1, 3 positions to one another, we can indicate it by using meta. So we just write M to indicate meta. So, and we have 2 bromine as a substituent, so meta dibromo. And benzene is the parent, so meta dibromobenzene. Okay, then we move on to look at the next compound. Can you see that the 2 substituent is at 1, 4 positions from one another? So if 1, 4 positions from one another, so means that they are in para positions with one another. So we indicate it using P. So means that it's 1, 4 position. So 2 bromine, so dibromo. And benzene is the parent. Okay, so the compound is called para-dibromobenzene. So now we move on to look at IUPAC nomenclature, where we have two different substituents. Okay, so when we have two different substituents, the highest priority substituent, okay, we can incorporate it as part of parent, and then if it is being part of the parent, then the carbon which is connected to the substituent that is part of the parent should be labeled as carbon number 1. Okay, so I will show this later on. Okay, and then one more thing you need to know is about the priority. Okay, so going down the table, basically the priority decreases. So basically higher the positions in this table, they will have higher priority. If lower the position, they will have lower priority, and usually they will become the substituent. So lower this table, then usually they will become the substituent. So benzene is here, somewhere here. Okay, so if higher the position, then that particular functional group, okay, so will be the parent, okay, will become part of the parent. Okay, so now we move on to look at how to name di-substituted benzene, okay, where one of the substituent will be incorporated into benzene to become part of the parent, and the carbon on the benzene must be labeled as carbon number 1. Okay, so like for example, this compound, so can you see that COOH has high priority? Okay, therefore it can be incorporated into benzene to become part of the parent, and this parent is called benzoic acid. And the carbon on the benzene, which is bonded to the substituent, which is now being incorporated into benzene to become part of the parent. So this carbon we need to indicate with number 1. Okay, so this is, we need to number it as carbon number 1. Okay, and then the other substituent therefore will be at carbon number 3 of benzene. Okay, and this substituent is called nitro. Therefore, this compound is called 3-nitro-benzoic acid. Okay, so and then NH2 also higher priority than the benzene, so can also be incorporated to become part of the parent. Okay, and the carbon of the benzene where it is connected to the amino group should be numbered as carbon number 1. Okay, and this is another substituent is at carbon number 4. Okay, but before we look at the another substituent, so the amino group incorporated into benzene to become part of the parent, we call this as aniline. Okay, and then another substituent, this is ethyl, is at the 4th position, so therefore we can call it as 4-ethyl aniline, or beside 4-ethyl aniline, we can also call it as para-ethyl aniline, since the ethyl is at the 1,4 positions to amino. Okay, so back to the compound just now, the nitro is at the 1,3 position to the carboxyl group. Therefore, we can also call this as meta-nitrobenzoic acid. Okay, then now we move on to look at the next compound. So this is carbonyl, so aldehyde. So quite high, the priority higher than the benzene. So it can also be incorporated into part of benzene to become the parent, and the carbon where the carbonyl group is attached to is carbon number 1. And this parent we call it as benzaldehyde. Okay, and then another substituent, we have bromine, so bromo. So it is at 1,3 position to the carbonyl group, so we can call it as 3-bromo-benzaldehyde, or we can also call it as meta-bromo-benzaldehyde. So how about if there are 3 substituents of benzene? So when having 3 substituents of benzene, we need to make sure that we give lowest possible numbers to the substituents. Okay, we need to measure lowest possible numbers given to the substituents. Okay, so when different substituents are present, when we name them, we need to list them in the alphabetical order. Okay, so like for example, the first compound here, the parent is still the benzene. But then how should we number the carbon on the benzene in order to give the substituent lowest possible number? So the best way is to number this carbon number 1, this number 2, number 3, number 4. Then we have the substituent at 1, 2, 4 position. So this compound therefore is called 1,2,4 tribromo benzene. Okay, 1,2,4 tribromo benzene. Okay, then we move on to look at the next compound. So the first example just now having 3 same substituent. So the second compound here we have different substituent. So how should we number them in order to give the lowest possible number? So we need to start with this carbon, then 2, 3, 4. In order to give lowest possible number to all the substituents. So the parent is still benzene. Substituent at the first carbon, we have chloro. So we have 1 chloro. And then we have 2 nitro and 4 bromo. When we want to name them, we still need to list them in the alphabetical order. So therefore, B, we need to list first. So therefore, the name of this compound is start with 4-bromo. And then C, so 1 chloro. And then 2 nitro. Benzene. Okay. Then now we move on to the last compound here. So benzene is still the parent. Okay, so how should we number in order to give the lowest possible number to the substituent? So can you see that we need to start with this carbon? And then this is number 2, number 3, number 4, number 5, number 6. Okay, so therefore the substituent will be at carbon number 1. So we have 1 bromo, and then 3 chloro, and 5 nitro. When we list them, again need to be in alphabetical order. So 1 bromo will be first, followed by 3 chloro, and then 5 nitro benzene. Okay, so benzene, sometimes it can also become the substituent. So when benzene become the substituent, when it is attached to the carbon chain with other functional group which has higher priority than it. Okay, so remember, benzene is here below alkyl. So if it is attached to other, okay, so within the compound having other functional group of higher priority, then the benzene will become the substituent. Okay, or when it is connected to a carbon chain with 6 or more carbon, then benzene straight away will become the substituent. Okay, so when benzene becomes substituent, it will be named as phenyl. Okay, benzene becomes the substituent, it will be named as phenyl. So shall we look at compound number 1? So compound number 1, can you see that this is your parent chain? Because it consists of 1, 2, 3, 4, 5, 6, 7 carbon. So it consists of number of carbon that is more than the carbon inside the benzene. Okay, so therefore, this carbon chain will become the parent, and that carbon chain with 7 carbon is called heptane. Okay, and the benzene therefore will become the substituent. It is attached to carbon number 2, therefore it is called it is substituent, and this compound is called 2-phenyl heptane. Okay, and then the next compound, can you see that this must be the parent because it consists of carbon-carbon double bond, which has higher priority than the benzene ring. Okay, and then this is carbon number 1, 2, 3, 4. So this parent, we call it as but-2-ing or 2-butene. Okay, and the benzene will become the substituent. It is attached to carbon number 1, therefore it is called 1-phenyl but-2-ing or 1-phenyl 2-butene. Okay, and then the last compound here, so alcohol higher priority than the benzene, so it will become the parent. So this is carbon number 1, carbon number 2. So this parent is called ethanol. And benzene here is the substituent attached to carbon number 2. So substituent is called phenyl. So therefore this compound is called 2-phenyl ethanol. Cikgu Shana, shall we stop for a while?
Yeah, okay. Let's stop for a while for advertisement. Okay.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, class. Before we continue our lesson with Teacher Tang, I will announce the next passcode. The passcode is number 1 and number 4. I repeat, number 1 and number 4. Okay, Teacher Tang, let's continue.
Okay, so now we move on to look at the benzyl group. So what is benzyl group? So just now I told you if benzene becomes substituent, it is called phenyl. So benzene attached to the parent chain, so this is called phenyl. Then what is benzyl? Okay, or benzyl group. So benzyl or benzyl group basically having a benzene ring, and then there's another carbon, one carbon, then only attached to a parent. So this group we call it as benzyl. Okay, so this group we call it as benzyl. So like for example, so this group here is benzyl and it attached to the hydroxyl group. So therefore this compound we call it as benzyl alcohol. Okay, so and this is the benzyl group attached to chlorine. Therefore, we call it as benzyl chloride. Okay, so the last compound here, so this is a benzyl group attached to the amino group. So this is amine class of compound. So therefore, it is called benzylamine. So now we move on to look at first question. So what is the IUPAC name for this compound? So I give you 30 seconds. So you tell me the answer A, B, C, D. So which one is the IUPAC name for this compound? $20 more. 10 seconds more. Any answer, Jigo Shannon?
No, still
Okay,
no.
not yet. Okay, so maybe I can give you the hints. So we have the carbon-carbon double bond, so which has higher priority than the benzene. Okay, so therefore the carbon chain with the carbon-carbon double bond should be the parent. So this is the longest continuous carbon chain with carbon-carbon double bond as the parent. Okay, so part of the parent. So we need to number in a way that the carbon-carbon double bond, the functional group having lowest possible number. So we need to start number from this one. So this parent, we call it as propene. Okay, so means that B definitely out already. So any answer from the student, Cikgu Shana?
Not yet.
Not yet. Okay, I continue give the second hints. So what substituent do we have? On the first carbon, we have this big substituent, which we call it as 1-phenyl. And on the second carbon, we have another substituent, which we call it as 2-methyl. So what is the name of this compound, class? Any answer? Any answer?
Still no.
Still no. Oh, yeah, never mind. Then I will give the answer. So the answer is A. Okay, so we need to measure, arrange according to the alphabetical order. So therefore, it is called 2-methyl 1-phenyl propene. So then we move on to look at question number 2. What is the IUPAC name for this compound? Okay, I give 30 seconds as well. Okay, so 20 seconds more. Okay, so ten seconds more. Okay, any answer, Cikgu Shannon?
No.
No answer. Okay, no answer. Okay, it's okay. So this is carbonyl. Okay, so this is carbonyl functional group. Okay, so the class of compound is ketone. So higher priority than the benzene, so can be included as part of the parent. Okay, so this carbon must be carbon number 1. Okay, and this parent, we call it as, so here we have 2 carbon, so acetal. Okay, so benzene, B, ketone, so non. So the parent is called acetophenone. Any answer from the students? Cikgu Shannon?
Still no.
Still no. Okay, never mind. So, okay, maybe they don't know. There's no answer. That's why they don't give answer. Okay, so substituent. Okay, so this is 4-nitro. Remember, if for 1,4 position, it is called para. Okay, so therefore, this compound is called 4-nitroacetophenone. Or it can also be called as para-nitroacetophenone. So there's no answer. That's why they don't give answer. Okay. So now we move on to look at the chemical properties of benzene. Okay. So benzene. Okay. So before we look at benzene, so shall we recap first? Okay. So before this, you have learned alkene. So this is cycloalkene. So alkene, in alkene, you learn that alkene undergo electrophilic additions type of reaction. So alkene undergo additions type of reaction where the carbon-carbon double bond can undergo addition to become two single bond. Okay, so become two single bond. Okay, double bond become two single bond. So this type of reaction is addition type of reaction. Okay, so in benzene, there are 3 carbon-carbon double bond. But you can never see benzene undergoing addition type of reaction. Okay, so if want to go addition, it also require a very harsh condition, then force it to undergo addition. So means that benzene, okay, it cannot undergo addition easily like alkene, which has carbon-carbon double bond. Okay, even though in benzene it has 3 carbon-carbon double bond, tapi it cannot undergo additions reaction easily like alkene. Kenapa? Okay, kenapa? It is because of the aromatic stability of benzene. Remember, I told you benzene, it fulfills the 4 criteria of aromaticity. Okay, because of that, benzene, it has extra stability. And this extra stability is due to itself being aromatic. Okay, and because of this extra stability causes benzene cannot undergo additions reaction easily like alkene. Okay, disebabkan oleh the extra stability due to this aromaticity. Okay, so then what type of reaction benzene can undergo? So benzene basically undergoing electrophilic aromatic substitutions reaction. Kenapa? Okay, it is because benzene having 6 pi electron. So means that benzene having a lot of electron is electron rich, high in electron density. So when it is high in electron density, it will react with electrophile. Therefore, the type of reaction it undergo is called electrophilic. Then why is it aromatic? It is because after the reaction, benzene want to restore its aromatic properties. Okay, it want to restore its aromatic character. Okay, so means that in the product, still mau ada cyclic, planar, completely conjugated, and still want to obey Harker's rules. Okay, so therefore, when we say the type of reactions benzene undergo, we say benzene undergoing electrophilic, aromatic. Then why is it substitution? So if addition, then it will lose aromaticity. It will become 2 single bond. Okay, so but then by undergoing substitution, whereby the electrophile replace one of the hydrogen on the benzene, then the aromatic properties of benzene can be restored. Okay, so therefore we say benzene undergoing electrophilic aromatic substitutions type of reaction. So now we move on to look at the electrophilic aromatic substitutions reactions of benzene. So it depends on the what is being used to what electrophile that is being used to replace the hydrogen on benzene. So if halogen is being used, then the name of the reaction is called halogenation. But the type of reaction is still electrophilic aromatic substitution. Okay, it's just that in halogenation, the electrophile is from the halogen. Okay, from the halogen. So therefore, one of the halogen atom will come in to replace the hydrogen. Replace the hydrogen. So this is your product of halogenation. But then remember, this is electrophilic aromatic substitutions reaction. So substitute the hydrogen, but at the end, the aromatic ring still dikekaukan, again being restored. So the byproduct will be HX. Okay, so remember halogen, diatomic molecule. So one atom used to replace the hydrogen. So another left will combine with the H to give you the byproduct. Okay, so then we move on to look at Friedel-Crafts alkylations. So Friedel-Crafts alkylation is still electrophilic aromatic substitutions reaction. Masih lagi this electrophilic aromatic substitution. But then now the haloalkane will give the alkyl group as the electrophile, okay, to replace the hydrogen. Okay, so alkyl group replace the hydrogen on the benzene, therefore is alkylation. Okay, but then is electrophilic aromatic substitution. After substitute, still mengekalkan the aromatic ring. So the ring is still there. Okay, so the ring is still there. And what is the byproduct? So the haloalkane halogen will combine with the H of the benzene, giving you HX as the byproduct. Okay, so we move on to look at Friedel-Crafts acylation. Okay, so from the name we know that the acyl group, so the acyl group will come in to replace the hydrogen on the benzene. Okay, so this acyl group from the acid chloride will come in to replace the hydrogen on the benzene. So here is the, can you see, here is the carbon that break with the halogen. Therefore, this is the carbon that will come in to attach to the carbon of the benzene. So this whole acyl group come in, replace the hydrogen on the benzene. But remember, this is electrophilic aromatic substitution. At the end, the aromatic ring still must be there, will be restored. Okay, will be restored. Okay, so why is this called Friedel-Crafts alkylation and this is called Friedel-Crafts acylation? It is because of the scientists who found alkylation and acylation is Friedel and Crafts. Okay, Friedels and Crafts. Therefore, this reaction is named after the scientists. Okay, so then we move on to look at the last electrophilic aromatic substitutions reactions on benzene. We call it as nitration. Okay, so nitration. So nitration basically use nitronium ion. So this is the electrophile that will replace the hydrogen on the benzene. Okay, so since the nitro group replace the hydrogen, okay, so the name of the reaction is called nitration. Okay, but remember, this is still electrophilic aromatic substitution. Electrophile replace the hydrogen, but at the end, the aromatic ring, the benzene ring, must be restored. Okay, so this is the product. And what is the byproduct? So basically, nitronium ion coming from the nitric acid. So can you see that nitric acid give nitronium ion means that what else left? H and O, one H and one O. So this H and O will combine with the H of the benzene, giving you byproduct water. Okay, so these four reactions, even though having different names, but they are all same type of reaction, which is electrophilic aromatic substitution. So basically, benzene reactions on the benzene is the type of reactions involve benzene is electrophilic aromatic substitution, where electrophile masukkan one of the hydrogen on the benzene. Okay, but at the end, the aromatic ring of benzene must still be restored. Okay. So for electrophilic aromatic substitution, just now I told you that benzene, because being aromatic, it is very stable. It is very stable. So means that in order to react with benzene, we need a stronger electrophile. We need a stronger electrophile. For halogenation, if we just use halogen, halogen is not a very strong electrophile. So halogen cannot undergoing electrophilic aromatic substitutions reactions with benzene. Then how can these halogenation reactions occur? It can only occur when there is a presence of Lewis acid. So this FeX3 or AlX3, they are Lewis acid. So what is the function of this Lewis acid? Basically, increase the polarity of the bond in the halogen. So we know that this bond is a non-polar bond, but by having this halogen react with the Lewis acid first, then this bond can be converted into polar bond, then easier, and then will give you stronger electrophile so that it can react with the benzene ring. Okay, in order for the electrophilic aromatic substitutions reactions to occur. So as in the Friedel-Crafts alkylation and Friedel-Crafts acylation, the presence of Lewis acid is a must in order for the bond between carbon and halogen to be broken easily. Okay, basically increase the polarity of this bond so that you can get a stronger electrophile to be formed, and the stronger electrophile can react with the benzene ring. So now just want to test you. Okay, so okay, shall we do this first? Okay, so maybe here is a hydrogen that we want to substitute. So shall we look at this? I give you 10 seconds. You draw the product. I don't want the byproduct, I just want the product. Could you please draw the product for me? Okay. You can write in the chat box the name of the product. So I give you 10 seconds. Any answer from the student?
No.
No. Okay, so no. Okay, so we can see that here we are having halogen. So halogen coming to replace the hydrogen. Okay, So we are using the halogen, therefore the name of this reaction is halogenation, but the type of reaction is still electrophilic aromatic substitution. Okay, so means that the electrophile is coming from the halogen. Okay, halogen substitute the hydrogen. So one of the halogens substitute the hydrogen. But remember, this is electrophilic aromatic substitution. So means that at the end, the benzene ring must be restored. It's still there. Okay. So maybe we move on to look at this reaction. Okay.
Yeah, we have one
Huh?
answer from Aina Maisara, bromo cyclohexene.
Huh? This is not cyclohexane, this is benzene,
Yeah.
Aina. Okay, so this is bromobenzene, Aina. Okay, it's okay. It's still a good try, Aina. Okay, so now look at this one. So 10 seconds. Any answer from the student?
Not yet.
Not yet. Okay.
They're still thinking.
Still thinking. Okay, I give the clue. So nitric acid, so the reagent nitric acid will give nitronium ion. So this is the electrophile, strong electrophile, so can react with the benzene. So to do
Okay,
the
we have an answer also from Aina Maisara, nitrobenzene.
okay, good. This is nitrobenzene. So this electrophile coming replace the hydrogen. So replace the hydrogen. Okay, but remember this is electrophilic aromatic substitution. Aromatic ring masih kekal. So it's there. And this carbon of the benzene is attached to nitrogen because nitrogen is the one that is positively charged.
Fitri,
Oh.
Zafandi. Nitrobenzene and water, question mark? The
Water is
answer.
the byproduct. Is the byproduct. Yes, yes. Okay, and this reaction, name of the reaction we call nitration. But type of reaction is still electrophilic aromatic substitution. Yeah, the byproduct is water. That is right, Fitri. Okay, then we move on to look at maybe this. So when you draw the product somewhere, you just type there done. I give you 10 seconds. Anyone done?
Not.
Not yet. Okay. So maybe I can give the clue. So just need to remember Lewis acid will form bond with the halogen. So let the carbon halogen bond to be able to be broken easily. Okay, to give you the strong electrophile. So strong electrophile. So basically this is your electrophile. So the electrophile will come in to replace the hydrogen on the benzene. Okay, remember this is electrophilic aromatic substitution. So this is the electrophile that come in to replace the hydrogen. So we can draw that part first. Anyone done?
No.
No. Okay, but remember this is electrophilic aromatic substitution. At the end, benzene ring is still there. And this carbon, so this is the hydrogen that is being replaced. So this carbon must attach to the carbon of the electrophile that is positively charged. So which is this carbon? So this is your product. And of course, the byproduct is HCl. Okay, the name of this reaction, so this is the acyl group coming replace the hydrogen. So the name of this reaction is called Friedrich-Krauss acylation. Okay, so then done? Anyone done? No one. Okay, I'm done. Okay, so then we move on to look at the last one. Okay, so the last one, okay, is this one. Also the same concept. We have this is the Lewis acid. So Lewis acid will form bond with the halogen. So increase the polarity of this bond so that this bond can easily break to give you the electrophile. Can you see that the bond is between carbon and bromine break? So the carbon here will become positively charged. And this is your electrophile that will come in to replace the hydrogen. So this is the part that will come in to replace the hydrogen. Remember, this is electrophilic aromatic substitution. At the end, the aromatic ring of benzene is still there. So this carbon is the place where hydrogen is being replaced. So this must be the carbon that attached to the carbon that carry the positive charge. So this is the product, and of course the byproduct is HBr. And the name of this reaction, so this is the alkyl group coming in to replace the hydrogen. So it is called Friedel-Crafts alkylation. Okay. Okay. So I think I will stop here. It's already 4:30, right? Okay, so that's it from me for today. Thank you, everyone.
Okay, thank you, Teacher Tang. Alhamdulillah, we are done with today's session. We have learned a lot from Teacher Tang about benzene, how to name benzene derivative according to IUPAC nomenclature, and also a little bit about chemical reaction of benzene. Okay, congratulations to those who are able to follow our session from the beginning till the end. And thank you very much, Teacher Tang, for such an interesting lesson. Okay, now it's time for me to announce the last passcode. The passcode is number 1 and number 6. I repeat, number 1 and number 6. And the presenter telegram is t.me/tangiu. Okay, and then don't forget to click the bell button too, so you won't miss out any news video and live classes from Teacher Tang. If you like today's class, then please click like and share to your social media friends. Let's share the knowledge you received today. Once again, I would like to thank to Teacher Tang for the interesting lesson. And thank you also to Cikgu Mawal and Teacher Kong for being with us today. I think that's all for now. See you in another session. Please do remember, stay at home and study. Goodbye, everyone. Have a nice weekend. Bye-bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.